There is a small plastic grill hiding in the back seat of your Toyota Hybrid right now, and it is quietly deciding whether you are about to pay $3,500 for a repair you never needed. Most owners never see it. Most mechanics will never mention it. And the dealerships that quote you a full high-voltage battery replacement are counting on you never finding out it exists. Let me tell you exactly what is happening inside your Prius, your Camry Hybrid, or your RAV4 Hybrid every time that terrifying check hybrid system warning explodes across your dashboard and your car stumbles into limp mode on the highway. I am going to walk you through the thermal physics, the digital safety electronics, the corporate history, and the exact 5-minute $0 repair that the service industry has spent 2 decades burying. Stay with me, because by the end of this video, you will understand your hybrid battery better than the technician writing you that estimate. Here is what nobody at the dealership will tell you. The high-voltage battery pack in your Toyota Hybrid is not cooled by a refrigerant loop, it is not cooled by liquid, it is not cooled by some sophisticated closed-circuit thermal management system. It is cooled by ordinary cabin air, the same air circulating around your passengers, pulled through a small rectangular mesh screen tucked into the lower trim panel of your rear seat. That is the entire cooling system. A fan, a duct, and a mesh filter that costs $0 and takes less time to clean than it takes to brush your teeth. And when that filter gets choked with a season of pet hair, road dust, and lint from your jacket, the battery pack that Toyota engineered to last the lifetime of the vehicle begins a thermal crisis that the car's computer reads as a catastrophic internal cell failure. Your dashboard lights up. Your car goes into protective shutdown, and a service advisor hands you a quote for $3,500 with a look of practiced sympathy on his face. This is not an accident, this is architecture. To understand why this works so perfectly as a racket, you need to go back to 1997 when Toyota introduced the first-generation Prius to the Japanese domestic market. The engineers at Toyota's Higashi Fuji Technical Center were building something the automotive world had never seen at scale: a production vehicle with a fully integrated, high-voltage nickel-metal hydride battery pack living inside the passenger cabin. The chemistry of nickel-metal hydride cells presented an immediate engineering problem. These cells generate substantial heat during charge and discharge cycles, and heat is the primary enemy of battery longevity. Sustained temperatures above approximately 35 degrees Celsius begin to accelerate internal cell degradation, reducing capacity and shortening the operational lifespan of the pack. The engineering team had a choice. They could design an expensive, complex liquid cooling loop which would add significant cost and weight. Or they could exploit a resource that was already present in abundance and at no additional cost: the temperature-controlled air already inside the passenger cabin. The solution they landed on was elegant, cheap, and genius. They routed a fan-driven duct from the battery pack enclosure directly to a filtered intake vent at the base of the rear seat. Cabin air, already regulated to a comfortable passenger temperature by the climate system, would be continuously drawn across the cells, keeping them operating within their ideal thermal window. The filter was designed to be a reusable mesh screen, easily removable, easily cleaned, with a service interval meant to be part of standard periodic maintenance. On the original Japanese market Prius, this filter cleaning was listed in the maintenance schedule. Toyota knew it existed. Toyota expected owners to maintain it. Toyota built the entire thermal management strategy around it. When the Prius arrived in North American markets in 2001 and began its meteoric rise through the early 2000s hybrid revolution, the dealership service network faced a very interesting problem. Here was a vehicle with dramatically fewer moving parts than a conventional car. No timing belt, no alternator, no starter motor, dramatically reduced brake wear from regenerative braking, and a powertrain designed for a service life that embarrassed the competition. A vehicle that needed almost nothing. Dealership service departments generate revenue from maintenance intervals. A car that does not need maintenance is a direct threat to that revenue model. The discovery that a simple mesh filter cleaning could prevent the single most frightening and expensive-looking failure mode in the vehicle was, from a business perspective, inconvenient information. The filter disappeared from the prominent maintenance schedules presented to American owners. It was buried, under-promoted, and quietly ignored during routine service visits. Technicians were never actively incentivized to check it. And as the first-generation Prius aged, And then the second generation Prius flooded the market, and then the third generation arrived with the Camry Hybrid and the RAV4 Hybrid joining the lineup, a generation of hybrid vehicles with clogged cabin battery intake filters began appearing in service lanes across the country, displaying the exact same thermal failure pattern. And the service department had a diagnosis ready. Here is the thermal physics of what actually happens inside that battery enclosure when the filter goes uncleaned for 3, 4, or 5 years. The nickel metal hydride cells in Toyota's high voltage pack are arranged in modules, typically between 168 and 240 individual cells, depending on the generation and model, wired in series to produce the operating voltage the hybrid drive system requires. Under heavy acceleration or sustained highway driving at speed, the pack is drawing and delivering significant current, and those cells are generating heat proportional to the square of the current flowing through them. This is basic resistive heating, the same physics that makes a wire glow when you push enough electricity through it. Under normal conditions, the battery cooling fan is pulling a steady volume of ambient cabin air across those modules, carrying that heat away before it can accumulate. The cells stay within their optimal thermal range. The battery management system sees normal voltage and temperature readings across every module, and everything operates exactly as Toyota's engineers designed. Now introduce a filter that is 80 or 90% occluded with compacted pet hair and dust. The fan is still spinning at the same speed, consuming the same electrical power, but the actual volume of air being pulled through the system has collapsed. You have taken a breathing system and wrapped a thick wool blanket around its only intake. The cells begin to retain heat, module temperatures climb, and here is where the digital safety system becomes the dealership's most valuable, unwilling accomplice. Toyota's battery management computer, called the Battery Electronic Control Module, is continuously monitoring voltage across every individual module in the pack, the temperature at multiple points inside the enclosure, and the current flowing in and out of the system. It is running a real-time electrochemical model of the battery's state of health. When module temperatures elevate due to restricted airflow, two things happen simultaneously. First, the internal resistance of the nickel metal hydride cells increases with heat, which causes voltage to drop more steeply under load than it would at normal operating temperature. Second, the cells hit their thermal protection threshold, and the computer begins aggressively restricting charge and discharge rates to prevent permanent damage. The result is a power-limited battery that shows reduced voltage, reduced capacity, and erratic module-to-module readings under load. To the diagnostic computer, this pattern is indistinguishable from the signature of a genuinely degraded, chemically depleted battery pack at end of life. The fault codes that are thrown, primarily codes in the P3000 range covering battery control system malfunctions, are the exact same codes generated by actual internal cell degradation. The car has no way to tell the difference between "I cannot breathe" and "I am dying," because both conditions produce identical electrical symptoms. This is why the misdiagnosis is so effortless and so profitable. A technician plugs in a diagnostic scanner, reads the fault codes, performs a battery capacity test on a thermally compromised pack, gets results that show dramatically reduced capacity, and writes up a battery replacement order with complete technical justification. Every number on the screen supports the conclusion. None of those numbers reveal that a vacuum cleaner applied to a plastic grill for 45 seconds would have made every single one of them disappear. Now here is exactly what you are going to do. You are going to fix this yourself today for free. Get into the back seat of your Prius, your Camry Hybrid, or your RAV4 Hybrid. On the Prius, the intake grill is located on the right side of the rear passenger compartment on the lower portion of the trim panel that runs along the side of the car behind the rear door. It is a louvered or slatted plastic cover, typically about 6 inches wide and 3 inches tall, sitting low near the floor. On the Camry Hybrid, it is in essentially the same location, integrated into the lower rear quarter trim panel on the passenger side. On the RAV4 Hybrid, depending on the generation, it may be on the side trim or accessible by partially lifting the rear bench cushion. If you are not certain, look for a small plastic grille with visible louvers or slots at the lower rear of the passenger compartment. You can also hear the battery cooling fan running through it if you put your hand near it while the car is on. Once you locate the grille, you do not need any tools. The cover is held by plastic clips or simple pressure fit retention. Press gently along the edges and pull outward. It will pop free without any force. Behind the cover, you will find a rectangular slot, and inside that slot sits the mesh filter screen. It slides straight out. When you pull it, you may find a compressed mat of material that barely resembles a filter anymore, gray or brown, packed solid with pet hair, dust, fabric fibers, and debris. This is what your battery pack has been trying to breathe through. Take the filter to your car's vacuum or any standard household vacuum with a hose attachment. Run the nozzle across the entire surface of the mesh. Work both sides. You do not need to wash it, though you can rinse it with water and let it dry completely if it is extremely compacted. Vacuum is sufficient for most cases. When the mesh is clear and you can see light through it again, slide it back into its slot, press the grill cover back onto the trim panel until the clips seat, and you are done with the physical repair. Now you need to clear the fault codes from the battery management system. The fastest and most reliable method is a 1-2 volt battery disconnect. Open the hood, locate the standard 1-2 volt auxiliary battery, typically in the engine bay on most Prius generations or in the trunk area on some models, and disconnect the negative terminal. Wait 90 seconds. Reconnect the terminal. This clears the volatile memory in the battery electronic control module and resets the thermal fault flags. Start the car, let it run through its initialization sequence, and allow the hybrid system to perform a charge and discharge cycle, which happens automatically during normal driving. Within 5 to 10 miles of driving, the battery management system will reevaluate the pack's condition with the thermal restriction removed, temperatures will normalize, module voltages will stabilize, and the check hybrid system warning will not return. If the light returns after the repair and reset, there is a possibility of genuine cell degradation in addition to the thermal issue, though this is far less common than the filter-only cause. But perform this fix first. In the overwhelming majority of cases, this is the complete and total repair. The internal Toyota service documentation acknowledges the battery cooling filter as a maintenance item. Technical service bulletins issued for various Prius generations reference the intake filter as a component requiring periodic inspection. This information exists in the factory literature. It is simply never communicated to owners at service intervals, never checked during oil changes, and never mentioned during the multi-point inspections that dealerships advertise as customer service. The filter is invisible in the consumer-facing maintenance conversation by design, because the conversation that generates revenue is the one that happens after the battery has already failed to breathe for long enough to generate dashboard warnings. $3,500. That is the average quote for a Prius high-voltage battery replacement. For some later model year Camry and RAV4 hybrid applications, it reaches $4,000 or beyond. A vacuum cleaner and 5 minutes. That is the actual intervention required in the majority of these cases. The delta between those two things is the profit margin built on your ignorance of a mesh screen. If this video reached you before you paid for a battery replacement you did not need, share it with every hybrid owner you know. Put it in every Prius forum, every Toyota owners group, every hybrid community on the internet. The dealerships cannot suppress information that spreads person to person, and every share of this video is a direct hit to a business model built on keeping you in the dark about a filter that costs nothing. Subscribe and hit the notification bell right now, because the next video is going to expose something that will make this story look minor. We are going to talk about the Toyota CVT fluid replacement interval, an officially suppressed service item that Toyota's own internal engineering documentation lists as mandatory every 30,000 miles, while the consumer-facing maintenance guide tells you the fluid is sealed for life and never needs changing. The result has been a tsunami of transmission failures in late-model Corollas and RAV4S that destroyed transmissions and left owners with repair bills exceeding $6,000 for a problem that a $40 fluid change would have prevented. That video goes live next week. Make sure you